Hi, my name is Dan Chrostowski, and this is my video for the copper engineering take-home assessment. So I looked over the question, and it looks like we're basically creating a system that will store historical key value pairs over time. So it's basically a time series. And yeah, it looks like we'll have a program which will be this class, and we'll have two methods, put and a get. So put will be to store the data, and get will retrieve the data with an optional timestamp. If the timestamp is not included, it will retrieve the latest value that was added for a given key. In my case, well, my plans are if there is no key, it will just return a null. Okay. I got my Visual Studio Code up. A few things came to mind after going over this question. And yeah, I decided to make three basic assumptions, which are probably important assumptions when considering a solution for this. The first is that efficiency is probably important. The second is scalability is probably important. And then the third is data persistence and access to this data is important. So when I thought about my solution, I kept those three things in mind. These are all important because if we were doing this for a typical large-scale production application, and let's just say I kind of want to make this sort of a store for, let's say, stock prices at a given date. So on the stock market, you have stocks go up and down throughout the day. I know some investment firms are tracking it to the second. So yeah, let's say we were to use this to store stock prices for every second of the day, for every stock exchange, for every stock. It would easily get very big. You'd have a very huge data set. So you need to consider scalability. And then efficiency, of course, you want it to be efficient. You want to be able to retrieve your data quickly and store it quickly. That's always a good thing. It makes quality applications, and being able to access that data is important. So ideally, a centralized location. I mean, depending on your needs, but maybe a cloud database storage option, something like that. So basically, the solution aims to be efficient and scalable, and also the data is accessible. So looking at the problem and the nature of the data we want to store and retrieve, my instincts told me this would probably be a good use case for a document-based database, or NoSQL database, as it's also known. This is great because I've got quite a bit of experience with NoSQL databases, specifically with MongoDB and AWS's DynamoDB. So the advantages of NoSQL databases are mainly that they are very fast and efficient, at least in comparison to the traditional relational databases like Postgres or MySQL. And also for this problem, there doesn't seem to be a real need for using data relations. It's just not useful for this. I decided I'm going to be using MongoDB for the solution, and only because I'm slightly more familiar with it, and I have some MongoDB related code from a few personal projects that I can repurpose. But this can easily be adapted for DynamoDB, which is kind of basically the same thing, but with different elastic scaling features provided by AWS. The first assumption of efficiency to be addressed. I did a little research, and I just learned about this. So Mongo has a time series collection type. So I looked through this and it seemed perfect for what this question is wanting, what we need in the solution. Um, so this looks like an ideal solution. I'm not saying it's the best, but it looks like, you know, using a MongoDB for this problem is probably the most efficient way to solve it. So according to the documentation here, MongoDB promises that this collection type will reduce complexity for working with time series data, improve query efficiency, reduce disk usage, and reduce I/O for read operations. So I think it's a good bet to use this time series collection feature to ensure that we are getting at least decent efficiency when storing and retrieving our data. There may be other options or data storage solutions which may perform better or worse, like DynamoDB maybe. But for the sake of simplicity, we'll just trust that MongoDB will suffice for making this solution efficient enough. When it comes to scalability, I want to note that MongoDB has a feature included called sharding, which is essentially a way to horizontally scale your data. Sharding is particularly important when you're working with enormous data sets, and vertical scaling will simply not be sufficient. So a CPU chip can only run so fast, and there are no hard drives with infinite storage space yet. So sharding is an option if this solution's data set becomes unmanageably large. I will not actually implement sharding in the solution. It's a little bit overkill, but it will serve as my answer to how would you improve this solution, or if you were to push this into production, anything you'd clean up, and how might you optimize the solution. So scalability has been considered, and sharding could be implemented to improve the solution if needed. Or you could also adapt this to DynamoDB and use whatever is available for scaling if you really wanted. And again, something like DynamoDB is most certainly comparable or even better when it comes to scalability. But again, I'm deciding to use MongoDB for my solution just out of personal preference. Don't get me wrong, I love AWS, and DynamoDB is also great. So I'll get started here. We'll open up VS Code. And open up a terminal. And I'm going to put this up on GitHub. I'll have a link included. So I'll just go to my Git directory, and we'll call this Copper Tech Assessment. And go in there. And then we'll just add this to our workspace. Okay. So the first thing we need to do is get a MongoDB instance. So I like to use Docker containers. They're neat little things, and I don't have to install a Mongo server on my machine. And some of one of my previous projects was it was a poker data miner. It used MongoDB, and I have a Docker Compose file all set that I can just modify slightly, and that should get us up and running pretty quick. So here is the Docker Compose file. I'll need to make some changes. Notably, this Mongo should be the latest because Mongo 4 does not support the time series collection. So I'm just going to copy this, and this is right off my GitHub. You can take a look at this. It's the poker tournament scraper. I think it's pinned on my homepage. But so we'll just copy that, and I'm going to make two directories. One will be for the Docker stuff, and then we'll make one for the code. Let's call it source, and I'll be using TypeScript for my coding. So we'll start with the MongoDB Docker. Make a new file, and it's going to be dockercompose.yml. I'll just paste that in. So I'm just going to change some of these things here. So Mongo is the service that we need, and we're going to make that Mongo latest. We'll call the container stockdb. We'll have an environment file which will pull this Mongo username, Mongo password. So let me actually create that now. And it's just a .env. I'm going to move that over to the right. Ports, let's go with, let's go with 4001. I think 2001, 3001 might be taken. Again, because there might be a Docker container still running that's holding some of my dev poker data. Volume, yeah, we'll change this to, and yeah, like we're gonna be calling this like a stock, like stock market ticker symbol and price store. So we'll call it stockdb. Network, what's it called? Stockdb network. That's not really a scraper. And then we're going to get rid of this service here. We don't need scrapers. And I'm going to run the node stuff locally, not inside the container. I think it's just a little easier for demonstrating. Just get rid of, yeah, all that. We don't need networks either there. So yeah, we'll call it stockdb network. Stock DB network declared there. And we don't need a node modules volume, but we should name this what we decided to call the volume up here, which was stockdb. Let's call it stockdbv, just so we don't get confused with the container name. Okay. All right, hopefully that should work, fingers crossed. So yeah, this is a Docker Compose file. It's basically just running like a Docker command, but I like to do it this way so you don't have to put in all the command line arguments, which can be kind of annoying. I think this is a lot better way to run Docker containers. So if all goes well, we're just going to go into the MongoDB Docker directory and do a Docker Compose up -- build. All right, I think it's up. We didn't put in the username. That's a problem. Let's try that again. We'll make the username stockbot and password will just be password. Again, not something I would use for production, but this is just a demonstration. And I might want to delete that volume and recreate it. Okay, let's try that again. So yeah, we just needed the username and password. For root. All right, and we'll run it again. Okay, it looks like it's running. I'm gonna test it real quick with a Mongo shell. And to make this a little easier, I'm gonna just go back to to my GitHub, and I always forget how to format these strings. All right, and I'm just gonna make a little scratch pad here. Wrap that. Okay, and you know, while we're at it, this will just be good for reference. The Docker Compose file isn't going to use all these, but it'll be good for later. So the host name should be localhost. The port will be, I think it was 4001, if I'm right. Yep. And we're going to create a database called stocks. That's what I'm choosing. And so my Mongo URL should be stockbot : password at localhost port 4001. And I'm going to leave out that database because it doesn't exist yet. And I'm going to just use this auth source equals admin parameter there. I think that should work. So I got a Mongo shell client already installed here. And this is just a test that we can get into the database. I'm going to use mongo sh, the URL. And it looks like it worked. We're in, authenticated. All right, so our Mongo instance is already up. So what I want to do is create the stocks database. So we'll just do use stocks. And what we're going to do is create a new collection that's a time series collection. And I think I have, if we go over to here, I'm just going to copy and paste this and change it a little bit, but this will basically create our time series collection, a blank one. So just copy that, kind of go into my scratch pad here. So I want to call the collection stock quotes. I like to use more specificity when naming stuff. And yeah, I like this. Date is a good field, ticker, and second. So to kind of go over like what this is doing. So it's basically just a standard collection, but it's doing some stuff behind the scenes where it's like creating indexes and being really clever about how it's going to be storing this data. But to us, it's going to feel like pretty much any other normal collection, but it's a special collection that will make this efficient. And yeah, all the information is on the MongoDB site about the time series. So if you just Google MongoDB time series collection, this should come up. I read through it. It all seemed to make sense. This looks good. So yeah, if you want to look at it, feel free. So yeah. Let's make that collection. So we'll just copy and paste this into the Mongo shell. And it looks like that worked. Now I've got another tool here I really like for kind of interacting with my Mongo databases. You can see I have some connections already. I'll make a new connection though. And copy this connection URL. Hopefully, if all goes right, this will work. Make a color. Copper is orange. Do orange on, but copper as the name. Sure. Okay, so I can see the stocks database that we have and the stock quotes collection. So we're good there. And again, that's a time series data collection. So that's all set. And the Mongo database is running. And again, if you want to try this, you'll just need Docker Compose, and you should be able to just spin up a MongoDB without much effort, just by running Docker Compose up. Okay, so now we have the MongoDB with our time series collection. We have to kind of work on the code that's going to facilitate storing the data and also retrieving it. And so, like I said, I'm going to be using Node.js and TypeScript. Going back over here, I like this. I guess this is maybe a suggestion, but yeah, I would make like a class with two methods, and we'll just call it TTKV. And yeah, so these two methods will be used. We'll use this program to store and retrieve data. So let's create. Let's initialize a node application here. I sometimes forget to do this, and then it's kind of a pain. So I'm just looking through some notes here. So we'll go into the source directory. Oops. We'll go into the source directory. I'll run npm init-y. This creates our package.json. And we'll install TypeScript. We'll also initialize the TypeScript compiler. Makes the tsconfig. We'll do the tsx. And this will basically just make it so TypeScript doesn't like yell at me too much. And we'll install the MongoDB npm package. We'll be using that. Okay, so that should be all set, and we'll create a new file, and we'll call this ttkv.ts. And we'll do the like the class style for this. I'm used to doing stuff with functional components, but like why not give this a try? Let's do a constructor. I don't know if we'll need that exactly. So we'll need to define our two methods. So we have put, which is going to take a key, which is a string, and then a value number. And that's gonna have a return type of void. So yeah, we can leave that like that for now. And then we want a get. And that will take key, which is a string, and an optional timestamp parameter that's going to be a number. Sure. So yeah, I'm thinking of make if it's got to be a number, I'd like to use like a Unix timestamp, and I'd like to actually, yeah, use like real time for this. I think that would be useful. So yeah, we'll take a Unix timestamp and figure out what the date is from that. And so this will return a number. It's got to be the value of the symbol, of the ticker symbol, the price, at that time that we specify, if we specify one at all. Okay, and to get rid of this red here, we're just going to return 0 for now, so get rid of those red lines. Okay, that looks good. And I'm going to just create another TS file, and this will just be the thing that uses the TTKV class. So we'll just call it like run.ts. So yeah, and from this file we'll be importing the TTKV class and playing with it in here. All right. So I think we can do something like this. We're going to import the TTKV class. Oh, gotta make sure to export. All right, and let's just kind of test to make sure everything's working. I'm just gonna put a log statement in here. It says put called and one for the get. Just so I know everything's working. This can be sometimes tricky. So we'll declare a variable, we'll make it a new instance of the class TTKV. I don't need to put anything into the constructor. And we'll just call ttKV.get, ttKV.put. What's wrong here? Oh, yeah, we need a key. Let's put an apple. And then the put, it needs a key and a value, a number. I think Apple is trading at like 200 something. Yeah. All right, and yeah, let's try and run that. So we'll need to, what I do to run TypeScript, I mean, there's a whole bunch of different ways. I just do a npx tsc that compiles it to JavaScript, and we'll type in run.ts. That should make a run.js. Yep, and I can see, yep, that's what it generated. And we'll just run node run.js. Get called, put called. Okay, so everything's working well. Now, we got our two methods in there. Now, in here. Now we got to figure out the database connection. So luckily, again, some old code. This can be modified slightly, and it should work. This is just, it just creates a connection based on some environment variables. I don't feel like typing all these in on the command line, so I'm just probably going to hard code them in. Obviously, that wouldn't be ideal for selling in production, but this is not production. We're just kind of doing a demo. So yeah, I'll just copy this. And again, I like to modulize my stuff. I like to use a lot of different files. It just so you don't have like a big mess of code all in one file. So this is pretty standard practice for me. So I'll make a db.ts file. I'll just paste what we had in there. And again, there's our Mongo connection string. I think this should pretty much work given we have all these correct. And if we remember, the end file that I made earlier has all that stuff in it. I can probably just kind of copy this and work this out. We'll get rid of this process.env and you know, make this all nice. So so I got two functions in here. It doesn't like, okay, so that was I took this from a JavaScript file, not a TypeScript file, so it doesn't like that. But basically, we got two asynchronous functions. All this will do is connect the client and then return it, and then this closes the client. So, and you just pass it back to the client. There's a bunch of ways you can do this. I believe like a pretty good practice, like you'll just want to open the connection, do something, if you like insert once or something, and then close it. You don't want to leave stuff open. So yeah, that's all this does. Kind of a little utility, and all we did was just hard code these values in. I think it should work. And we export these two. So I'm going to go into our TTKV class, and I'm going to import these. I think it's going to be import, yeah, connect client, and close DB connection from, I think that should work. And so yeah, pretty much on every put and get, I want to open up the connection and then at the end close it. Now, again, these, if you remember, move this over here. These are async, yeah, I really like the await syntax. It's just a lot cleaner. So I'll be doing that. So I have to make these two methods asynchronous. And they'll basically return a promise. And so we'll do once client equals connect client. Oh, await connect client. And we will call at the very end here await close DB connection, and we'll pass it back to the client. Okay, we'll do the same in the get method. Okay. And I would like to confirm that this is actually going to connect. Oh, we have a problem here. So I think we need to make the return type a promise. The type of void. Yeah. And then same here. It's going to be a promise of type. It's going to return a number. Okay. That looks good so far. So I do like to incrementally run things, just make sure we're on the right path here. So we'll compile the run.ts, and that should compile everything else and run it. Get called, put called. I'm gonna assume we connected. I guess we'll find out when we start putting stuff into the database. Okay, so again, so our key is going to be like our ticker symbol. Our value is going to be the price of the ticker symbol. So this is probably going to be easy to start with. Oh, and we wanted to associate this data with a timestamp. So every time this is called, I'm gonna basically get the current timestamp. So we'll just call that a variable now, and assign a new date, and that should give us the date when this executes. And we got our client. Yep. Okay. And then we got to do db. So client.db stocks is our database name. Remember? Yep. Stocks. And our collection was stock quotes. So and then here's what our stock quote object's gonna look like. So we need the date. And we'll set that to the now variable. Ticker, which will be the key, the ticker symbol. And the price, which will be the value. So that's what's going to be stored in. So it's basically going to look like the current date, whatever key was passed in, whatever the price was passed into here. And then we're going to do collection.insert1 stock quote. Now I believe insert1 is asynchronous, I think. So we'll put an await there. And then I'm just gonna, for debugging purposes, just log inserted data. And just log the quote data. And yeah. Actually, what might be more useful, we can say inserted price value for ticker symbol key at now. So kind of know what's going on. We'll just get rid of that stock quote. Alright, and now I guess it's time to test this method. So go over to the run.ts file. So yeah, alright, so I'm gonna, this should hopefully insert to that MongoDB instance. So we're gonna put in Apple, $200.56. I'll go back here, just make sure this is empty. Good, empty queries like that. There's nothing in there. So once we run this, we should have something in there. So we'll compile the TypeScript. And there's a problem. Oh, this thing. I'm going to package.json. I think gotta specify it's a module, and that should fix it. TypeScript is so much fun. Oh, I'm trying to run the TS. Maybe we didn't need that. There, okay. Yeah, we were fine. This is kind of what I don't like about TypeScript, but whatever. So we have here, let me make this bigger. Inserted price 256 for ticker symbol Apple at Friday, April 25th. So let's go in here and look at our data. Sure enough, here's our time series collection. So we got our date, our ticker, and our price. Great. So the put method's working. So we could probably move on to the get. And we can get rid of some of these log statements. Actually, I'll just comment them out in case we want them later. So the logical next step is just called get Apple, but we'll need to query the Mongo collection. Yeah, we'll leave the get call. I'm gonna zoom out a little here. So yeah, we'll just kind of copy what we did over here. Get the collection, the database. So I believe collection's got a function or method or whatever you want to call it, called find one, and I believe it takes like a query like this. So we'd want to look for a ticker that equals our key. So yeah, let's just run that. I'd like to just log the result. So we have, this run.ts is just going to call the get method on ticker symbol Apple, no timestamp included. Okay, and yeah, I got it back. Now let's just, let's put in a ticker symbol that we haven't put into the database. Amazon. And the result should be null, I believe. And it's null. Okay, so I think this basic get is working. Now the tricky part is working the timestamps into this. There's Mongo can allow you to search in a date range, and there's some documentation on it here. And this is specific. This is a specific example for the time series collection, and I think they have an example. Yeah. So they're using they're calling the find method, and under date, this means greater than or equal to this date and less than or equal to this date. So it's looking for dates between these two. So that's going to be pretty critical to this thing working, because we want to be able to basically get a stock price on a particular date or a timestamp. But we only want to return one, obviously. So again, I was looking through here, back to the example. So this makes sense. So at t equals 2, we put a as the first value, 5 a at second value, and 9 a at third value. So so yeah, if we put in time 8.2, we should get second value because third value hasn't been put in yet at 8.2. But if it were 9, we'd get third value, right? So my first thoughts on this was, well, we can probably just put a less than or equal to into the query under find one. So I think that would look kind of like this. We'll just kind of indent here. So we'll do date. And I'm trying to, it's like $LTE. Oh, so we need to put something in for here. So we got to do something with this timestamp parameter. And now, it's kind of bothering me that it's a number. I would also like it to take like a date time, which we can do. So either a number or a date time. So the number would be a Unix timestamp, and then date would just be a date. It could make someone's life easier. So, and yeah, I don't want to put a number here. I think it wants a date. So let's change timestamp to either a number or a date, like that. And we'll declare a variable here, and we'll call it LTE parameter. And we'll default it out to a new date, which would be the current time. So we'd want that because if we don't pass a timestamp, then you're going to want the first value that was inserted at a date less than or equal to the current date. So that would bring up only one date. However, it gets a little tricky because when you're doing find one, Mongo is just going to return back the first one that it finds, which won't really be useful. You want the latest date, right? But there are ways we can work with that. There is an options parameter that can be passed to this find one, which I'll get into. But for now, I'll get into that later. We'll take this LT parameter and just put it here. So this should work for the default case where you don't provide a timestamp. And yeah. Now I want to put in an if statement. So if type of timestamp is a number, I'm just gonna take that and turn it into a date. So I think you can just pass in a number. And now if it's a Unix timestamp, that's seconds. When you pass in a number to date in JavaScript, it's counting that as milliseconds. So that's pretty important. So yeah, it would be your Unix timestamp times 1,000. And then we want to also handle, if you want to just pass in a date, it wouldn't be type of, it would be timestamp is instance. Is that it? This is kind of wacky syntax I'm not really used to. Instance of, I think it is. Yeah. In that case, we'll just set the LT parameter to timestamp. Parameter. Okay. Okay. So yeah, we can accept either a number or a date. So in the case someone uses this timestamp, we'll set that LTE parameter to the time they wanted. And then it's going to start, it's going to just find one database record in the collection that meets this. But again, so that's going to be a problem because it's probably going to turn back the very first, presumably, record that was put in for that symbol. So a way around that is we can add a second argument to this find one, and this is the option. So we're gonna put in a sort option, and we want it to sort the records by date descending. So it's gonna basically like do that whole query, but come back with the latest states first. So it's gonna bring you back a record for that ticker symbol that is the first one before or at this timestamp for sure. So that sort there is very important. And yeah, so I would like to check if that works, but we don't right now. We only have actually, yeah, this could work. So if we change this back over here in the run.ts, change that back to Apple, and then this will be our timestamp argument, and I can look over here at the date, and I can just copy this. Oh, that didn't work. So if I move this back 1 second, so it was 39. We'll put it at 38 seconds. The result should be null. So we should log a null. Let's run that. We did get a null. Now if I put it back to the date that's in the database, we should get, it should log a result, and it should show this record. So let's try that. Oh, I forgot to compile. Okay, it did not work. I wonder why. Do a little debugging here. Okay. Try just copying this again. Okay. Maybe if we move this up in time. Still no. Okay. Not sure why it would do that. I would like to probably log what LTE parameter is. wonder what would happen. Let's make sure the data is still there. Let's just put in another. We'll insert another record for Apple. And then we'll check the. There's the new record. So we got different date. And this is future. We can actually make sure we stay in order here. No, that's not it. Filter. No. Okay, sort. Just make sure this stays sorted by date descending. Okay. So let me copy. This is the later entry. And I'm gonna use this get again. You know, these are, I wonder if this async has something to do with it. I'm gonna make kind of an async function wrapper. We'll call it get values. So we'll just run get values. And we should see this record logged, hopefully. And it's still null. I'm wondering, here's why. That should be date, not data. Let's try that again. There, okay. Just kind of the stupid things that happen when you're programming. So yeah, we got back the record at time 005739. 005739. Okay. Now, so yeah, let's make this at 38 seconds. Now, I should expect to log not this record, but this first one here, where the price is 201.56. So let's see what happens. Of course. Let's kind of format this. I'm just going to copy this and make sure I'm not going crazy here. So we want Apple at a date of this or less than this date, equal to or less than that date. That's null. Okay, this is the original. I'm just looking at the time. I'm not reading it. Yeah, 01, 13, 59 is in the future, is future to this. So it would make sense that it returns null because there is no record for Apple before that date. This is your latest. That was another, making a lot of stupid mistakes. So this is kind of the timestamp we want to check against. Okay, so we take this, turn this back 1 second, and correcting myself here, we should get this bottom record where it's 256. Hopefully. Okay, 256 seems to make sense. And then let's try that with the later record. Yeah, so let's put it back to how it was. And this should return the later record for Apple that we have. And that value would be 201.56. And we got 201.56. So that appears to be working. Okay, and we're almost done here. We just need to, instead of log the result, we want to return back the price, or the value. So we get rid of that log statement. Now, probably what we'll want to do, so if result does not equal null, return result and then price, like that. And then our default case will be to return null. And it doesn't like that. Oh, okay. We need to change this return type here to either number or null. Okay, so we'll either return number or null. And we'll just make sure we're getting a number back. So I'm assigning price value 1 to the result of the get call. And we'll just log it. So yeah, we'll just leave that get the same, and we should just get back 201.56. We got back 201.56. Yep, and then let's take 1 second off of this. And then we should get 256 back. 256. So that appears to be working. We can definitely test this more. There's usually some edge cases that happen, but I can't really think of any right now. A good practice would be to run like unit tests, like with Jest or something. I'm not going to do that. It's just kind of a lot of work. But what I could do is write some assert statements to make sure things make sense. So one thing that we need to consider when we're putting values into this database is when we created our time series. So we have we set a granularity to seconds. So when we're putting stuff in, we probably want to space these out a bit. Otherwise, everything will there will be a lot of things going in at the same second. So I'm just going to write a little helper function here to kind of space out our records a little bit. And yeah, I tried earlier. I tried to create a time collection with granularity set to milliseconds, and it didn't like that. So seconds it is. I don't know why you would need to know the stock price at every millisecond, but seconds is probably good. Yeah, probably good. Yeah. So yeah, oh yeah, I was gonna make the little helper function that will kind of it would be kind of like a sleep function, just to space out our puts. So I will call this wait ms, wait milliseconds, and it has to be an async function. So we'll return a new promise with the resolve going into the function set timeout. Right, we want to specify how long we want to, how many milliseconds we want to sleep, and then this is TypeScript, so call it a number. Okay, so what I'm going to do is in our put values function here, I'm just going to put in a bunch of different ticker symbols and prices. And then a, I don't know, like a wait of 1500 milliseconds in between each. They're not all going to be Apple. So we could put in Amazon, I don't know, like 416, Tesla, I don't know how close these are to their actual prices. I know Coca-Cola is KO. And we could vary some of these weights. Doesn't all have to be 1500 milliseconds. And then yeah, we'll throw. It doesn't have to be in any specific order. We'll just put like another Apple price update there. And we'll make it a really volatile trading day. Another Apple here. I just want to vary up these numbers as well. Another Amazon. We'll make Tesla take a big hit, which seems to be kind of matching up with reality right now. Okay, so this put values function, this is just going to insert. I kind of just put in Apple, Tesla, Coca-Cola. So these will all be put in an order. So we'll get rid of this get values and we'll change up the put values. And we'll look back at our data here. So we still have our two Apple records, but once we run this, we should see a bunch more. Everything looks good. And hopefully this wait function will work. I did a run.js. And yeah, it's taking a while. I guess, yeah, the waits are working. There's nothing really indicating that. We could put back this log statement, although it just finished now. But yeah, actually, yeah, I'm pretty sure it's in there. We'll check our data here. So yeah, we got a bunch of new ones. So this, it looks like, yeah, the latest ones are on top. Let's this might sorting it this way might make more sense. So we have our earliest records in first, and then they go down. So I want to write some assert statements to kind of prove that this is working based on the data we have. So I'll just make a new function. It's kind of like get values. And let's import the assert. And you do that like this. All right, so we're not gonna put any more values in. So we're kind of done with that function. I'll just leave it in here though. We'll make a run test. And this is going to be a little bit tedious, but right now it's kind of like the most straightforward way I could think to test this. So let's go for... So yeah, let's just run a get without a timestamp for each of these 3 ticker symbols that we have in here, and kind of figure out like what price it should return. So we'll do we'll get Apple without the timestamp in there. So this price value 1 should be the latest price in the database that Apple was set at. So again, we're starting at earlier and going to later. So it looks like this is the first Apple I see going down the list. So it should give us 176.46. And then I'll just write an assert statement. Assert.equal price value 1, and what did we say was 176.46. And before we go too far, I want to make sure I didn't do anything stupid. Nothing happened. And then yeah, let's just change it to something that it shouldn't be, and we should have assert yell at us. It's gonna be like, no, it's not supposed to be 176.47. Right. So we got an assertion error. Okay. So basically, if we can get through this run test, and we're gonna try different scenarios, without us getting an assertion error, I would say pretty confidently that this works. You know, pending a QA test, right? So yeah, we'll just keep doing this. So we'll do a get for Tesla without any timestamp. So we'll change that to Tesla. And let's look at the latest price for Tesla, which would be $56.86. And then we'll do one for Coca-Cola. Oh, we also have Amazon. So the latest Coca-Cola price would be $95.31. And we'll just do Amazon. And the latest Amazon price is $212.56 right there. I already forgot. $212.56. All right. And then we should test our null case. So let's query a symbol we don't even have in there. ABC. That might be Google. And we'll assert that the return equals null. And I'll even I'll log it here. So yeah, let's run that, and hopefully we shouldn't have any assertion errors. We do. Interesting. So it's pulling out. Did we put an ABC in there? I want to run it through here. That's not making a whole lot of sense. When did we put ABC in there? Oh, Again, another stupid mistake. I was checking price value 1. We want to look at price value 5. That would make sense. Okay, so no assertion errors. So yeah, that indicates to me that it's working. But I don't know what this is all about. I think that might just be the way it... I don't think that's correct. Or it might be just showing us this for some reason. Or maybe I'm not... Oh, that's because I'm using the project. I want to do this. Okay, yeah, there's no ticker symbols for ABC. Sorry, just a lot of mistakes today. I'm going to kind of blame it on the newborn and not enough sleep. But at least I'm catching them and figuring it out. Okay, so those test cases look good. And then, so yeah, let's kind of pick a date and make sure from our data, let me get rid of this filter here. So just pick like a random record here, Tesla at this date. And remember, 2/5/7/24. 2/5/7/24. Oh, that should go in the assert statement. So we want to put in that timestamp. That I didn't copy. There, that log statement. And we'll put an assert. I have to go back here to reference this, so it should be 2/57/24. And then let's change that date slightly. Another test case. So let's go back 2 seconds and then look for the previous Tesla record. There is none, so we should get back a null in this case. The assert looks like it went through okay. And I know this video is probably getting kind of long, so we'll just pick one more. Maybe we'll do an Apple. There's a lot of Apple records. 2 more test cases. So let's kind of do the same thing with this record. So we should get back a 20356. I'm just going to copy these. So we'll put in this date, which should give us back 20356. And then we'll push this back 18 seconds, so that's 2 seconds earlier. And that should bring us to the previous Apple record, which would be a price of $201.56. And compile that. Everything works. I'm going to get rid of that get called log statement. That's kind of annoying. And we don't need to log the date. So yeah, this here is pretty much your solution, I think. The solution to the question. So yeah, I will push this up to GitHub. I'll include the link. It should be public. You should be able to access. You can look it over. Again, this is probably like what you're looking for. And again, this is just kind of me putting data in there and testing it. But yeah, I think this is a pretty good way to solve that problem and really consider efficiency and scalability. And again, there's probably other ways to do this. Again, like DynamoDB comes to mind rather than Mongo. But you know, with all the work I've done with Mongo and all the code I have, like a lot of the other work I've done with DynamoDB has been with private companies. I'm not allowed to, you know, keep that code, but yeah, I've done a lot of personal projects with Mongo, so I just decided to use that, and I think this would work. I think this would scale well. Obviously, if you were set out to record every single stock on the New York Stock Exchange at its price at every second of every day, you're obviously going to need to horizontally scale this. Like this one MongoDB instance running in a Docker container will definitely not cut it. But again, that's where I kind of talked about sharding and horizontally scaling out your infrastructure. So doing it this way, it kind of leaves the door open for that. So yeah, I'm just gonna end it here. Yeah, thanks for watching this. Thanks for your consideration, and hope you have a nice day.